let's go to the next slide. Okay. Machine learning is a well-established field in computer science for decades, or I guess for some aspect for the 50s, and became on the front line about 70 with the new expert system developed, such as MySyn, developed to face to automatize some specific diagnostic system or for other application. In the middle of the 80s, a new approach derived from computational neuroscience and has emerged. It was the machine learning based on distributed processing, more well known as neural networks approach. The machine learning is an element of artificial intelligence. It's not is the basic on which one creates in automatic way or new knowledge or find new relation in the data that for a specific field and a specific application. Obviously, to improve or to optimize the capability to extract rules, to manage technology, or the statistical part for data control, for consistency of the data. This data warehouse that Professor Pasadani described in a previous lesson are fundamental. As fundamental are the evaluation and the development of function for likelihood of cost function to determine the discrepancy in a trained system from a new presented exam or a new presented object and the categories are learned by the system. Deep learning is the evolution of machine learning. Many of the tools, many of the architecture are strongly related with the models developed in the 80s, but is improved the capability of the systems in the machine learning. For instance, we want to consider backpropagation system is the original form was hard classification of one of two classes or more classes, but using a very simple architecture. In the deep learning, the evolution of computational architecture can lead to more to generate a like order or representation. Then one can synthesize to say that the deep learning is more adapted to working on high order concept formation. Actually, I synthesized the main class of deep learning systems that are the first is called generative deep learning. Is a kind of algorithm dedicated to extract high order correlation, or taking into account the Professor Pasadani lesson. This is the problem to find concept, to analyze the logical, the meaning of the that is embedded in the data that you are analyzing. This information is suitable for pattern analysis or to obtain distributional property of the data. The discriminative deep architecture is used to classify or to partition the data in a hard or fuzzy or soft classification in different groups, such as several types of cluster methods or other. The other hybrid architecture are obviously combine different methods in order to enhance the capability of concept abstraction or to manage this information. This an hybrid architecture is designed, specifically designed for a specific task. For instance, for image analysis, for satellite analysis or other. For the basic applications such as biomedical application, except obviously imaging, one can decide, generally one that use generative or discriminative architecture. Otherwise, because the development of hybrid deep architecture require more time and require also the possibility to have a test case to test the performance of the new model that is generated. The normal classification of deep learning is similar to the machine learning methods. Generally, in this figure you can see the supervised and unsupervised method that are split by the vertical arrow, and the shallow and the deep. This is essentially on the top you can see on the top left you can see the logistic regression, perceptron and SVM that are the classical machine learning methods. On the other side, supervised, you can see the the deep neural nets, the convolutional neural nets, the recurrent neural nets that are the elements, the architecture widely used for many applications, from microarray analysis to diagnosis and so on. On the bottom you can see instead the unsupervised method, the noising autoencoder. Autoencoder was originally developed in the 70s. I do not know how many knows the Hopfield net or other, and this Hopfield net was one of the first autoencoder system. The other restricted Boltzmann machine is a variant, variation on the Boltzmann machine. That is the original Boltzmann machine is a mechanical statistic origins, that derived from the problem of optimization in chemistry and physics. And sparse coding is a different form of coding systems. On the other side, the deep, you can see the same, more or less the same approach extended into the deep, extended to extract high-order knowledge. Please think. The origins of deep learning and the new generation of machine learning, because the original was in Mycin, for instance, the rules was syntactic rules that was implemented in the software. If the rules was programmed, and you can and the rule was very fixed. I have used it and tested some decades ago Mycin, and was very rigid for same response. And the failure was Mycin was developed to predict antibiotics, or to find what is the best antibiotic for a specific pathology. And sometimes was really rigid, because, for instance, the addiction of new antibiotics required the writing of new rules, and it's not too much adaptive. The original neural network was a perceptron. You can see in the pink color, more or less are supervised, are a class of different original neural networks. The first is the perceptron, feed-forward network. There are networks that propagate the input on different layers, and for each layer is computed an error. And the radial basis function is a system on which each neuron represents a normal, generally a Gaussian distributions, and the classification is performed according roughly speaking, according the distributional property of the input. Autoencoder is similar to the encoder that we have seen, and Hopfield network is an autoencoder. The Boltzmann machine, as I said, is in the 80s was very complex to run a Boltzmann machine because the original algorithm was very time-consuming. Now it's possible to do. On the other part are the deep network, and you can see that essentially we have the deep convolutional network. Is repeated 2 times. One is the CNN, convolutional neural network. Okay, one is convolutional neural network, and the other is the convolutional neural network. Starting from, in general, they start from architecture such as feed-forward network or backpropagation systems. They are some kinds of feedback. In the 80s, there was a set of different architecture that does not widely applied in those periods. There was, for instance, adaptive resonance technique that was, and neoconic neutron, that is a network that allowed to have a feedback and an adaptation of the weights of the connection by direct feedback on each layer and on each element of the layer. I have written in red the coherence self-organizing map only for effective point of view, because it's my favorite class of algorithm. I am working also now on this kind of network because they are unsupervised network. If one compare the original algorithm, now there are many variations that allows to extract from unlabeled data logic connection about the informational frame in your data. Thanks. Okay. Now there is in terms of new generation of machine and deep learning, I guess it's important to define some kind of knowledge. Why? Because during the performance evaluation of a systems, you have you normally use AUC, area under the curve, or receiving operating characteristics that give the level of performance, the level of the error of your systems. But what is an error? If there is a missing data, an error could not be an error, could be an exception to a rule. This depends on what kind of knowledge do you have. The knowledge is the information, the meaning that is available about one object. There are 3 types, 3 levels of knowledge. The first is the explicit knowledge. The explicit knowledge is the information. When I said, for instance, the DNA is macromolecules, I can communicate this information, and this information can be easily coded in a machine-readable way. In the same way, the results of a microarray is explicit knowledge because there are the data. Then you can code this data and you can use this data without any problem. It can be generally coded in a textual or numeric form or symbolic form. Is the general form of data. Strings, number, structure, what you want, image, and so on. Implicit knowledge is derived from the explicit knowledge. And it's derived by application of explicit knowledge. Roughly speaking, the implicit knowledge cannot be represented by a variable, but this is embedded. If, for instance, if I record, if I give an experiment, the result of PCR, the result of PCR, for instance, obtain a specific value. But there are other parameters. For instance, the temperature in which the experiment has been carried out, the ionic strength of the medium. What do you want? Microarray, the same. The experimental condition, i.e., the number that you can see include several variables that are not coded. Then, when you can have the results of your prediction, you have the prediction of explicit knowledge. You must, in the terms of data warehousing, it's the implicit knowledge, having information about it, is important to control the quality of data, or to control the homogeneity of data, the type of chip, the temperature, the condition, the cell lines. The cell lines is explicit, but the condition in which the cell line was grown, no. The third is the tacit knowledge. The experience derived by individual experience. The more simple example is the cooking. I mean, the recipe of Indian recipe is changed by family and the recipe passed from a generation to another only by the experience of your grandmother and so on. In a science point of view, scientific point of view, in some way is the experience of the operator. If you learn to use an instrument, there is an expert that teaches to you how to use. Then normally this tutor has a great experience in this instrument and transfer to you his knowledge. But this knowledge cannot be coded. Essentially, these two types of knowledge are not easy to be coded or to extract from machine learning. Our knowledge is covered. Thanks. Okay, you have simplified the previous line this way. If the knowledge is communicable, or if the knowledge can be coded, can be put into your data set for train, or not communicable, then it is split into technical, because I do not communicate, for instance, how an instrument works, or cognitive, because depends by the capability to acquire the information and put this information in the it is used, it's transparent, it's a ghost information. Okay, you can see that logical relation CE and BC, in a general sense you can see that this relation DB and DA show the transitive property from one relation to the other, or from one concept to the other. in the circle, in the ellipses, other available knowledge. The relation are the basic elements, the true and validated elements for data mining. The other is available knowledge that can be also used, but outside the ellipses, the unavailable knowledge. For the same object, we cannot use all the information that is available. In this case, it's the problem to data source integration, or for instance, web mining system, or using different different paths that are not the normal databases. These things. We can come back to the data that one can use can be structured. The structured record is a SQL form that is well known, or other form to organize the knowledge according into the database in a standard format according the need of according the necessity of the task. Semi-structured, they are not organized in data repository, but they contain data that allow to make a reference with the basic data, with primary data. And unstructured data are information that cannot be fitted in a specific data model. For instance, a text cannot be fitted in a model. You can say, okay, but PubMed is a database. PubMed is a database, but the text of the abstract and the database are not structured, are not fitted to the model of the. It's a field of a structural record, but the text is not structured. Cannot fit to any structure. It's not possible, because if I have a set of experiment, I said experiment 1, variable 1, 2, 3, and name and notation what you want. But a text you cannot split almost. Cannot split in different. This text cannot split into different fields of database. It's all the text is a feature. Okay, is an element of the record. Thanks. Okay, this is my fil rouge that connect the lessons. Like we can skip it directly, because in any case, recall the other lesson, please. And okay, sorry, come back one. As I attempted to split the exposome problem into into 5 different subfields in order to check to highlight the difference and the problem that we have for each subfield. Obviously, we're talking socioeconomic data, epidemiological data that someone this morning have talked with me, or environmental data, climatological data. My feeling is that, for instance, socioeconomic data, taking into account the knowledge discovery, is more complex, because the tacit knowledge or implicit knowledge in this kind of data is quite high. Also in epidemiology, or also because sometimes some option was not directly coded into the report or into the database. Then the statistic protocol are standards, but what is the quality of the team, or what is the performance, or what is the time, or for instance, only the statistical criteria for critical region definition, for acceptance and other as being must be not communicated, not always communicated. Statistics, yes, because you must give this kind of information, but other situation, not. For instance, in the collection of data about interview, how to manage or how to organize into classes the interviews. I decided for classes, no bad, intermediate, good, very good, or 10 classes. You have the results, you have the survey, but you cannot have information, too much information about the structure. The environmental data are experimental and more or less quantitative. The problem is that if the information is measurable or not. This is the please. Okay, you can see here an attempt to give you some possible application of machine learning and deep learning in each subset of the exposome process. The geochemical anomaly, landslide susceptibility, in this case you can predict, you can develop some knowledge discovery because the data allows to, the events, geological data allows to attempt rule generation. The same also for climatological, because we have standardized data about meteorology and other things, fluid, thunderstorm, what you want. Molecular biology is well known. In any case, gene expression, protein structure, protein ligand interaction, regulatory domain, relation between proteome and disease, and what you want. There are a huge amount of the papers that work on it. Clinical is the same, but clinical, as I said, is affected in some way by implicit knowledge, because the diagnosis is normally, in some cases, not only obtained by lab screening, but also with the writing of the clinicians. Then there is not a standardization of how to write it. Now there is a international consortium, HL7, that push toward the standardization at the international level of health record. Otherwise, we remain with the different linguistic difference that different doctors have. The last point is interesting because it's the drug repositioning. But the drug repositioning derived by the cost to develop a specific drug for a specific disease for a specific target. If the compound fail to have a pharmacological activity on the established target, it's possible to put the same compounds in a pipeline to find alternative target, alternative pharmacological target. This is, roughly speaking, the drug reposition. In this case, one can also predict what are other possible targets. Why? Because the data are measurable. There is the data coming from experiment in which the big problem, the only one of the error factor is the quality of the screening, or is strongly related to experimental activity. The last, social behavior, the demography. Now there are studies that use machine learning to predict the violence, to predict if someone make more than one crimes, the violence in many different social way, performance of the students, and now also the Brexit process has been submitted to a prediction systems, and the political sentiment analysis, as you can see, I collect interview and